morning, good afternoon, good evening, maybe, and welcome to this webinar. As the title suggests, what we're going to be talking about is security of Java applications, and specifically in terms of what we're addressing in this webinar is looking at the security of the JVM layer underneath your applications, because as I'm sure as Java developers and Java users, you're aware that writing a Java application, you compile it into bytecodes that runs on top of the JVM. And the JVM introduces this layer between your application and the operating system underneath. So there's as much that you need to consider in terms of security for the JVM and the JDK as there is for the operating system that you're running your applications on top of. So we'll be talking about all the different aspects of that and how to ensure that you have the best possible security for your Java applications. The first thing I'd like to talk a little bit about is how things have changed in terms of the Openjdk release model, because this actually feeds into what we're going to talk about in terms of updating the JDK and making sure that you have the latest security patches and so on. Back in 2017, JDK 9 was released. And at that point, Oracle made a number of announcements about how they wanted to change the way that the Java platform itself was developed. In the past, we've been used to a number of years between releases of the Java platform. So it could be 2, 3, even 4 years between major releases. And Oracle said that in terms of going forward, they wanted to switch that so that we would have a release every 6 months. So every March, every September, we would get a new version of the JDK. And we've seen that this has worked very well so far. If we look at 2018, we got JDK 10 and JDK 11. Then in last year, we got JDK 12 and JDK 13. Already this year, we've had JDK 14, and the work on JDK 15 is very advanced. So in a couple of months, that will be released. And I have to hand it to Oracle to say that they have done a very good job of making this much faster release cadence work very well. It has required work in terms of making sure that things like the JCP, the Java specifications have had to be generated much more quickly than they were in the past, but Oracle have done a good job of that. And this has been a smooth process where we have seen that we've been able to adapt to this much faster release cadence, and we're seeing much more in terms of features being released more quickly. Now, the reason that Oracle gave for doing this was that they wanted to make the development of the JDK itself more agile. And if we think back a number of years to how we used to do software development, it used to be the case that we used the old sort of waterfall approach where we do all of our analysis, all of our requirements capture at the beginning, then we do all of our analysis, then we do all of the design, then we do all of the coding, then we do all of the testing, and we deliver the result. By which time probably the users had moved on and needed different things in the application. Now we use agile methodologies. So we're much more adaptive, we're much more iterative in terms of our approach. So we gather some requirements, we write some code, and then we go back and we say, well, okay, has anything changed? And then we can adapt, we can build more functionality and do that in a much more iterative way, as I said. So it's moving away from the idea of having as Oracle tried to do 2 years between releases, which they never did, to the idea of this 6-month release cadence. To do that, what has had to happen is we've had to change the approach of how features are included in each JDK. In the past, the features have driven the release. And by that, what I mean is that if we look at JDK 9 as an example, the big feature in JDK 9 was modularity, dividing up the libraries that are in the Java platform into more manageable modules, and then allowing a runtime to be built that only includes the modules that you need for your application. Great for things like microservices, great for things like embedded systems. And so that's where we had the idea that the feature was driving the release. So JDK 9 was going to include modularity, and it had to be ready in order for JDK 9 to be released. What we saw was that because of the complexity of that feature and the fact that there was feedback from the community in terms of the wider Java community, it actually resulted in the release of JDK 9 being delayed twice. If you try and apply that to a 6-month release cadence, then it's not going to work, because very rapidly as soon as you start delaying a release, it's going to then bump into the next release and it's all going to become very messy. So what we do now is we say, okay, well, now we'll let the release drive the features. Essentially what happens is every 6 months at a certain point, we draw a line and we say, whatever is ready at this point, we will include in that JDK. Anything that's not quite ready, even if it needs a couple more weeks of work, that goes into the next release. And because it's only 6 months away, it doesn't really make a difference because people are not going to be too upset if they have to wait 6 months as compared with 3 years for the next major release as it was before. So this, as I said, is a very good way of doing things, and it seems to be working very well. However, this has had a big impact in terms of how we have extended support for individual releases of Java. In the past, what we've been used to is that Oracle would provide updates to the current release of the Java platform, which is what we have expected. But they've also provided a nice overlap between the current release and the previous release. Again, let's use JDK 8 as an example. When JDK 8 was released, there were updates to JDK 7 for over a year after that release, which gave people time to make the migration from JDK 7 to JDK 8. They didn't have to do it on day one. They didn't have to straight away use that new version. They could take up to a year, over a year, to make the migration from 7 to 8. With a 6-month release cadence, this is not practical because very quickly we're going to end up with literally, maybe 5, 10, even 15 versions of Java that need to be supported for, different updates. And that's just really not practical. What Oracle decided to do at that point was that they said for the Oracle JDK, this is quite important, I'll come back to this, for the Oracle JDK, they would provide long-term support for one release every 3 years. The idea being that if you wanted to move more quickly in terms of features, then you could update every 6 months to a new JDK. If you were more concerned about the stability of your platform for the long-term idea of deploying your applications, then you would use the long-term support version, which would change every 3 years. And in fact, you could continue using it for more than 3 years if you wanted to. So this is quite important in terms of how we're looking at support for updates. To get things started, they classified JDK 8 as a long-term support release. And they said that they would continue providing public updates, ones you could use for free, until January of 2019, last year. And that was for commercial users. So that means that up to JDK 8 update 202, those are free, publicly available updates. For people who are using Java for personal use, if you're at home playing Minecraft on your PC, then you will still continue to get updates through the Java update tool until the end of 2030. So you can continue playing Minecraft on JDK for quite a long time yet. The first of the new long-term support releases for the Oracle JDK was JDK 11. And what this means is that the other releases, JDK 9, 10, 12, 13, and 14, are all feature releases. And that means that these are releases that don't have extended support and updates, meaning that after 6 months, there are no more changes provided to those versions of Java. So you shouldn't be deploying anything on JDK 9, 10, 12. 13 is an exception, and I'm going to come back to that when I talk about what we do at Azul with medium-term support releases. But for all those other ones, those are only supported for 6 months. Now, in terms of updates, this is quite important. As I said, the Oracle JDK, the binary distribution, has long-term support versions. This doesn't apply directly to the Openjdk source code. So the source code doesn't have the concept of long-term support versions. In terms of other providers of Openjdk binaries, people like Azul, people like Amazon, people like Red Hat, and so on, we have all adopted the same approach. So we're all following the idea of long-term support releases, and they will be the same ones that Oracle have done. JDK 8, JDK 11, the next one will be JDK 17. What Oracle also did, which was quite significant, was when they released JDK 11, the Oracle JDK 11, they changed the license that they used for that. Prior to this, they had used what was called the Oracle Binary Code License for Java SE. And that essentially said that you could use that version of Java for your applications for free, so long as you were using them on a server, on a desktop, on a laptop. The restrictions for that license were more to do with embedded systems. So the field of use restriction said that if you were building an embedded system or a single purpose machine, like a ticket machine or a kiosk type of idea, then that would require a different license. But for more general purpose computing, desktops, laptops, servers, completely free to use the Java from Oracle. In JDK 11, the license was changed to what's called the Oracle Technology Network License Agreement. And what that says is different to the previous license. It says that you can still use the Oracle JDK freely, but in 4 different situations, and only 4 different situations. First is for personal use, if you're playing Minecraft at home. Secondly, for development use, if you're developing code for an application, you can do that. Or if you're using it for Oracle-approved products, like their middleware, their database, and so on, or for the Oracle Cloud infrastructure. Anything other than that, so if you wanted to use the Oracle JDK 11 in your data center for your application and a web-based application, then you would require a Java SE subscription from Oracle. You would need to buy that from Oracle in order to be able to use it under those license terms. JDK 8 is a little bit different because JDK 8 was initially released under the Oracle Binary Code license, meaning you could use it freely. At JDK Update 202, things changed, or after JDK Update 202, things changed. And that was the last public update that came out in January of 2019. The update that came out in April of last year, JDK 8 Update 211, and all the subsequent ones after that have been available on the Oracle website, but they're now under this new license, the Oracle Technology Network License Agreement. So that means that you cannot use those updates in a production environment unless they fit into one of those 4 categories or you buy a Java SE subscription. So you need to be very careful if you're deploying Oracle JDK into your environment that you're not using one that has a different license on it, which would mean that you would potentially have to purchase a subscription or get audited. So what I'd like to do now is I'd like to ask you, the audience, a question. And if we can bring up the poll, which we do here, my question is, how frequently do you update your Java runtimes? And I've given you 4 possible answers here. The first is that you update every time there is an update and you do it as quickly as possible. So you are the best possible person in terms of making sure your Java runtimes are as updated as possible. Second one is that you only update if there is a critical security patch that needs to be addressed. And the third one is only when we have updates to applications. So if you update your application, you also update the JDK runtime. And then the last one is we don't update our Java runtimes. And so I think we've probably had long enough for that. So if we can bring up the results now, so we can see that what people said, then hopefully we'll see the results. There we go. Yes, interesting. Okay, so I've done this webinar twice already today. I did one for the Asia Pacific region, I did one for Europe, and now we're doing one for the Americas. And the results here are slightly different. So interesting to see that a fifth of the audience, 21%, actually do update as quickly as possible. In both of my previous webinars, nobody did that. The majority of people update when there's a critical security patch that needs to be updated, and that fits in with what I saw in the other 2 webinars. And then we have, again, around a little bit less than a third who only update when they update their applications, and a smallish number, 14%, who don't update Java runtimes at all. And that sort of fits in with the breakdown that I had in the other ones, other than the fact that nobody in the other webinars was updating as quickly as possible. So it's good to see that some people are doing that. Okay, so going back to the slides, let's talk about vulnerabilities. Now, vulnerabilities in software are defined through what we call CVEs, and this is common vulnerabilities and exposures. And this has been set up by what's called the National Cybersecurity Federally Funded Research and Development Center that's hosted by the MITRE Corporation. Essentially, a CVE is a description of something in software, and it could be an operating system, it could be Java, it could be an application, where that software can be exploited through some way to avoid security checks and therefore expose either information or a denial of service attack or something like that. But it's a vulnerability in terms of the software. And that description contains a certain number of fields of information. So it contains things like a description of what the vulnerability is. It contains information about whether the vulnerability can be accessed remotely over a network or whether you need physical access to the machine. Then it describes certain aspects of how the vulnerability can be used in terms of different pieces of software and so on. Another important thing of each CVE is a CVSS, and that's the Common Vulnerability Scoring System. And what that does is it gives you a number which indicates how serious that vulnerability is. As we can see from the picture here, there is a sort of slightly older version, which is CVS 2.0, and then the one that we use at the moment, which is CVSS 3.0. It's actually 3.1 that we use now. But essentially, the values that are associated with each CVE are divided up into groups, so you know roughly what the implication of those vulnerabilities is. From the version 3 idea, none is 0.0, which obviously means that there is no vulnerability, so I don't know why we'd have a CVE if it has a 0.0 score. But then we have low, which is 0.1 to 3.9, medium 4 to 6.9, high 7 to 8.9, and then critical, those are the nasty ones, 9.0 to 10.0. And it's important to understand that, because obviously what you want to be looking at is what is the breakdown in terms of CVEs that are addressed in each update, so that you can decide whether to deploy that update into your environment. How important is it to use updates? So we saw the results of the poll, and some people update very quickly, some people don't update at all. What's the implication of that? Well, what I did was I went back and I looked at all of the updates for the Java platform going back to January of 2017. And in this case, what I did was I looked at what was the highest CVSS for each of those updates. And we can see here that the highest we've had is 9.6. That's a pretty nasty vulnerability. And the lowest we've had is 5.9. So even then, that was, it was quite a, it was a medium, but it was, something you might have to consider updating for. And obviously a range of values between that. The red line I've drawn here shows where public updates from the Oracle JDK stopped. So April last year, that's when updates to JDK 8 no longer were publicly available. You couldn't deploy them into a production environment. And interestingly, the high scoring CVSS in that update was a 9.0, so a critical vulnerability. And I looked into that in a bit more detail, and it turns out that was actually something that wasn't even part of Java. It was a Windows DLL that was used to build the JDK. So the vulnerability was in that library, but because it was used as part of the build environment for the JDK, it's something that would need to be addressed through updating the JDK itself. And as we can see, we've had several updates since then, and most of them have, medium to high level scores. Looking at that in a slightly different way, what I did was I went back through all of the updates from January 2015, so a bit over 5 years, and looked at all the CVEs that were included in those updates, and then based on, broke it down in terms of the bandings of those CVEs. And we can see that there were a total of 320, and certainly there was, a reasonable number of low ones that we don't need to be too concerned about, quite a lot of medium ones, 147, but then there was still a significant number of high, 56, and then I broke critical down into 2 categories. I said 9 to 9.9, 35 of those, and then I said how many of them were actual 10s, 10.0s, the worst possible vulnerability you can get, and there were 24 of those in the last 5.5 years, meaning that if you haven't updated your JDK in that time, then you're potentially exposed to a significant number of vulnerabilities. The last thing I want to say about how important updates are is that certain industries also have compliance issues that they need to be aware of. If you're in things like finance, if you're things like energy, if you're in things like utilities, then there are lots of protocols, there are lots of standards that you need to adhere to in terms of computer software. Many of these say that for any software that's being used in those type of environments, it always has to be kept up to date with the latest patch for security and bug fixes. And there are a number of different standards for this. There's things like critical infrastructure protection, there's things like payment card compliance, and so on. So it's just important, if you're in those type of industries, to understand about whether you need to ensure that your applications do have the latest patch level for all of the software that's running on. Now, let's look at an interesting real-life example of how this could be significant. And what I found was this very interesting one, which was in 2018, August 22nd, there was a vulnerability that was identified in Apache Struts. And I'm sure many people on the webinar already know about Apache Struts. It's a thing that's used for web-based front ends so that you can deliver a user interface to an application. Very popular, open source software used in lots of applications. A vulnerability was identified. Okay, we understand that, from time to time, these vulnerabilities do get identified and people find them because complex software is very difficult to eliminate all of the possible problems that you could have with it. On August the 22nd, the vulnerability was identified. On August the 23rd, one day later, GitHub had a proof of concept code posted for how to use that vulnerability and an exploit that you could use to take advantage of it. So literally one day later, somebody posted some code, how to use that and how to exploit it. One day after that, on August the 24th, somebody posted on GitHub again a Python script that used that exploit to enable people to take over people's machines and be able to use them for doing crypto mining. That's 2 days. 2 days from a vulnerability being identified to it being available to anybody through GitHub to be able to exploit it and do crypto mining on your machine. So that's the kind of thing that you really do need to be aware of in terms of updating your JDK. Another thing that's important to understand is about how we go about testing the JDK. And so we have this idea of the JCP, the Java Community Process. And originally that was designed as a standards body that provided all of the standards for the Java platform, and that included everything. Now, since then, there have been some changes. So the enterprise side of things has moved from the JCP over to the Eclipse Foundation. It's now Jakarta, and so that's being handled separately. But in terms of the Java core platform, Java SE, that is still defined by the JCP. And each version of Java has its own Java specification request. There's an expert group associated with it, and they develop that and provide the definition of the specification and so on. And a JSR consists of 3 distinct things. It's quite important to understand this. So the first is there is a specification, and that defines exactly what goes into that version of Java. It defines what the Java virtual machine does from a functional perspective, how it should process bytecodes, what bytecodes it should respond to. It defines all of the library code in terms of which libraries are available, which APIs and so on, and it's a full specification of the Java platform. The second thing that you get with the JSR is a reference implementation. That's an implementation that proves that the specification is unambiguous and can be implemented. In the case of Java, Java SE, that is Openjdk, the open source code that has been provided for each release. There's a repository for each release, and that is a reference implementation of that standard. And then the third part of the JSR is what's called the Technology Compatibility Kit, or TCK. This is sometimes referred to as the Java Compatibility Kit, or JCK, and that consists of over 150,000 tests which can be used to verify that a binary distribution that has been created of Openjdk, because that's a reference implementation, or another implementation of Java, passes all of those tests in order to say that it does conform to the specification. That gives you as the user a very good level of confidence and assurance that if you run an application on the Oracle JDK, which is past the TCK, and you move it to a different JDK, let's say Zulu from Azul, which has passed the TCK, then from a functional perspective, it will run in exactly the same way. The bytecodes will be executed in the same way. The application will behave in exactly the same way. So it gives you that assurance that moving from one version to another in terms of the binary distribution, your application will still run in exactly the same way. Okay, so let's talk a little bit about what we at Azul do in terms of providing you with a build of OpenJDK. And what we do is we call this Zulu. Zulu is a build of OpenJDK. And we describe this really as an enhanced build of OpenJDK. And I'll kind of explain that. So the first thing we do is we take the source code from the repository in the OpenJDK project, and we then make a few changes to it and we build it. Having built that binary, we then run that binary through all of the 150,000 tests that make up the TCK, and we ensure that all of those tests pass, meaning that because it passes the TCK, you have that assurance that from a functional perspective, it's the same as any other OpenJDK or JDK that passes the TCK. What we try to do is provide the best possible set of versions and platforms that we can to address all of our customers' needs. We actually go all the way back to JDK 6. So our supported versions are currently JDK 6, 7, 8, 11, and even 13. And I'll come back and talk about why we support 13 in a couple of minutes. We go as far back as JDK 6 because that's the first version that was available under open source. Technically it was JDK 7, but there was a backport done so that there was an open source version of JDK 6. Anything before that, JDK 5, 1.4, was closed source and it wasn't open source, so we can't provide builds of that. As I said, it is an enhanced build of the OpenJDK because there are some other things that we do as well. What we've seen is that a lot of people want to continue using JDK 8 because of the issues in terms of migration to later versions. And so we've decided that to add value to Zulu 8, we'll backport some features from newer versions to Zulu 8. And the two things that we've done so far, one is flight recorder support, so that flight recorder was available in the Oracle JDK 8, but it was a commercial feature, meaning you had to pay for a license if you wanted to use it in production. So they open sourced that in JDK 11. We've subsequently backported it to the OpenJDK code, so you can now use mission control to interact with your JVM, interact with files produced by flight recorder, and look at what your JVM is doing from a performance perspective using Zulu 8. The other thing that we backported, which is very relevant from a security perspective, is TLS 1.3, Transport Layer Security. That's the latest version, so it gives you better security for web-based applications. And we've done that in such a way that you don't have to modify your code, you don't have to recompile your code, you can simply turn it on by using a command line flag, and that's all you have to do to use it. So it's a simple, straightforward thing to do. In terms of platform support, we cover the standard platforms you'd expect. So Intel 64-bit versions for Windows, for Mac, and for Linux. And then for some of our customers who want support for older versions of operating systems, for example, Windows XP, and they need 32-bit versions, we have JDKs that run on 32-bit Windows and Linux. This really is a drop-in replacement for the Oracle JDK. You can simply take your application running Oracle JDK, move to Zulu JDK, and everything will work in exactly the same way. CPUs and PSUs. This is quite important because one of the things that Oracle do for their commercial customers is they provide two different versions of each update. And what Azul do is we match that. So we do exactly the same thing. And as far as I know, we're the only people other than Oracle that do that. The first of those is called the Critical Patch Update, or CPU. And what that includes is only the changes which are relevant to the security-related fixes, so security patches. So any CVEs that need to be addressed, that's the code that goes into the Critical Patch Update. This is designed so that we have the minimal set of changes that you need to address those security issues. so that if there's a critical or a very high vulnerability that needs to be addressed very quickly, then you can do minimal testing of your application, make sure it at least starts, make sure it will do basic functionality, and then you roll out the security patches and get them out very quickly so your applications have the maximum level of security protection as quickly as possible. The patch set update, or PSU, contains all of those security patch changes plus everything else that goes into that update. So any bug fixes, any minor enhancements, any other code changes. By having the CPU that you can roll out very quickly if you need to, that means that you can then take more time to use the PSU and run maybe a full set of regression tests, check that everything works in exactly the same way on this latest update without having to worry about security issues and having to address those, so that you can be confident that your applications will run in the same way with this update. What that gives you is the maximum level of stability for your application. So the CPU is about maximum level of security, the PSU is maximum level of stability. How important is having a CPU? Well, it's interesting because there's a very topical example. The July 2020 update came out only a couple of weeks ago, and in that we had JDK 8 update 252, and that's the patch set update. If you look at the numbering system that is used in the OpenJDK, then you have update, the even numbered update is the PSU, the odd numbered update is the CPU. JDK 8 update 252 had a significant regression. And by that, what I mean is that somebody put a fix into JDK 8 update 252, which fixed one thing, but it unfixed something else. So it actually broke some code. And there were several common applications, things like Hadoop Cluster, Solr, Lucene, which were broken by a fix that was included in update 252. If you had access to the CPU, that didn't include that particular fix. So the fix was part of the PSU, but it wasn't part of the CPU because it wasn't security related. So that would mean that if you were worried about the fact that the update in July had a CVE which had a score of 8.3, and you said, okay, well, we really need to address that in our systems, then you could roll out the CPU and have that security vulnerability addressed, but you don't need to worry about the fact that the PSU also included this change which would break things like Hadoop Cluster and Solr and so on. You could then wait for another update to come out, which will happen shortly, which includes a fix to the fix, so that you can then roll that out and have the full PSU available for your system. So again, it's about having maximum security, but also maximum stability. In terms of extended support for Zulu, what we do is obviously we look at the changes that are made by Oracle and other people to the current release of the JDK, because that's the only place where changes are made directly to the Openjdk project. So currently it's JDK 14. All of the changes for each update are made to that particular source code repository, JDK 14, and we see those changes. What we need to do as a provider of binary distributions is take those changes and backport them to the older versions which we support. So 6, 7, 8, 11, 13, we backport those changes. And in terms of how long we're going to do that, for our long-term support release, because as I said, it doesn't have a technical meaning, it depends on who you ask what their long-term support means. For us, long-term support means that we will continue to provide you with the regular quarterly updates for 9 years from the release of the JDK. After that, we'll also give you a further 2 years of passive support, meaning that we won't provide regular quarterly updates, but during those 2 years, should you find a problem with the JDK, we will provide a fix, we will then build a new update, and we will provide that to you as a customer. So you effectively have 11 years that you can use each long-term support version for. I mentioned a couple of times the idea that we're providing medium-term support releases. And so we decided that in addition to the long-term support releases, we'd also offer the idea of medium-term support releases that address the idea that there are 3 years between LTSs. That means that if there's a feature that you really want to use in one of those releases, you might have to wait 2.5, 2 years before you can actually deploy it into production. So now what we do is we say, in the case of where we are now, JDK 13 and then JDK 15 are medium-term support releases. We will provide you with updates to those until 18 months after the next long-term support release comes out. That gives you 18 months. Let's say you deploy JDK 13 because you want to use it. So that gives you then 18 months after JDK 17 is released to migrate your applications from JDK 13 to JDK 17. It's kind of a bridge to the next long-term support release. Looking at the various versions that we provide support for, how long we're actually going to do each of those, it's a little bit more complicated because some of the older versions obviously didn't fall under the traditional or the idea of long-term support as it was defined. So in case of JDK 6, we're providing support until the end of next year. JDK 7 is July 2023. JDK 8, because that's the one that a lot of people want to continue using, we're going to continue supporting that until December 2030 at the moment. JDK 11, current long-term support release, will be provided updates until September 2027, and then JDK 13 until March 23. Same for JDK 15, and then JDK 17, the next long-term support release, until September 2030. In terms of Azul's Java credentials, it's important to understand how we can actually offer this service, and you can have confidence that we can deliver on what we're trying to provide. So we have a lot of engineers who work for us that have a lot of experience in terms of Java. They used to work, many of them used to work for Sun, many of them used to work for Oracle, some of them used to work for both. But we have a lot of involvement in Java outside of that. We are a company who only does Java, and we like to get involved in all different aspects of that. We have been a member of the JCP Executive Committee since 2011. I'm one of the people who gets to sit through the JCP meetings or the EC meetings, which can be quite interesting. I'm also a representative for Azul on the Java SE expert group for each JSR. We've been doing that since Java SE 9. We're currently up to Java SE 16, because although Java SE 15 hasn't come out yet, we're already starting work on Java SE 16. Importantly, we are a member of the Openjdk vulnerability group, and this is a group that was set up by Oracle as a closed group within the Openjdk. Again, give credit to Oracle for thinking about this, and they said that because they were changing licensing and the way that updates were made available, they expected there to be more binary distributions of the Openjdk, and they wanted to make sure that users had access to secure versions of that. So the vulnerability group is a number of companies or representatives from companies who provide binary distributions of Openjdk. There's Azul, there's Oracle, there's Red Hat, there's SAP, there's IBM, and so on. And what we do is we work together collaboratively. So when a CVE is identified that affects Java, we work together to provide a patch for that. And that's what goes into the updates. It goes into CPU, it goes into PSU. The important thing for us is it means that we are able to see those changes that are going into each update before the update is released. So we have visibility of all the changes, and that enables us to do the backporting and to do all the TCK testing before Oracle release the update. Then when Oracle do release an update, we are able to provide our version of the update for our supported platforms very, very quickly after Oracle do theirs. Because remember, if you've only got 2 days potentially between a vulnerability being identified, it's in the list of things that are in a particular update, and somebody having a version of an exploit that can be used with that, you need to be able to roll out those changes very quickly. So if we look back at the last year and a bit to last April, all of the updates we provided to our customers, we have done so within an hour of when Oracle released their update to their customers. Now, in terms of timings, I think the fastest we did was 22 minutes. After Oracle, the slowest was 59 minutes. But that gives you an idea that effectively, we are releasing our updates simultaneously with Java. You know, the most that people have had is 59 minutes as a window of opportunity. They would have to look at the list of CVEs that have been addressed. They'd have to figure out how to exploit that. They'd have to find systems that haven't been patched and then try and exploit them. within 59 minutes. So I don't think that's really an issue that we need to concern ourselves with. From the other sort of point of things, OpenJDK projects, we also support those. So one of our engineers is the lead of OpenJDK 6 project. One of our engineers is the lead of the OpenJDK 13 project. We upstream changes that we backport to those into those projects as well. So just to summarize, basically, in terms of keeping Java applications secure, from the point of view of the JDK, what you need to consider is a number of different things, and all of these things are addressed by our Zulu builds of OpenJDK. First thing is, are the builds that you're going to use TCK tested? Having the assurance that they pass all those tests and therefore it conforms to the specification, and you know that any other build that runs that has passed TCK, your applications will run in the same way. Do you have a defined service level agreement as to how quickly updates will be made available after Oracle release theirs? If you don't, you could potentially be waiting days, maybe even weeks before that update's available. And that's a window of opportunity for hackers to exploit that vulnerability. Are all security patches and bug fixes going to be backported for all updates? So what we've committed to is backporting anything that is relevant. Clearly, if JDK 14 has a feature that doesn't exist in JDK 7, we don't need to backport that fix. But anything that's relevant from JDK 14, we will backport to all of the supported versions. Does your provider provide both the CPU and the PSU, so that if you need to roll out security patches very quickly, you can do that with a smaller set of changes? And do you have the traditional form of support in terms of 24/7 ability to pick up the phone, give us a call, send us an email, and so on? What we're doing with Zulu builds of OpenJDK is about maximum security, maximum stability, maximum flexibility as you as customer. And obviously the idea is to offer that at a lower cost. So that is the end of the webinar presentation. So what I'll do now is I'll just have a look to see whether there's any questions. So if you do have any questions, then obviously you could type those into the Q&A box. So there's one here. How difficult is it to migrate to Azul? What level of resources and processes are required? Yeah, this is a question that actually comes up a lot when we talk to potential customers. People will say, well, hang on, so we're using Oracle. How difficult is it to move to using Zulu? And the answer is it's really very straightforward, because, as I said, the key thing is that what we're delivering here is a like-for-like equivalent runtime. So you don't have to recompile your code. You don't have to change your code. You don't even have to change any of the command line switches you use in your startup script. You don't have to change your startup script at all. So it is very simple in terms of making that migration. In addition to providing all those different platforms that I explained earlier, we also provide all of the formats that you would expect for deploying the JDK onto different machines. If you're using Windows, we can provide you with a zip archive. We can provide you with an MSI installer file, so you can do it automatically. If you're using Linux, again, we can provide you with a compressed tar file for manual installation. We can also provide you with RPM files. We can provide you with deb files to do automated installation. For Mac, it's the same thing, either compressed tar files, zip files, or a DMG file for automated installation. So all of that means that it's very straightforward in terms of deploying Java in terms of Zulu onto the machines, and you can use the same process that you use for deploying any other update that you would normally get from Oracle. So it's very straightforward. And we've had a lot of customers who've done this, and I've talked to a lot of them and explored this, and they really haven't found any issues in terms of actually making this migration. Okay, so another question, is it available for PowerPC? Yes, it is actually. So we do have builds of PowerPC, because one of the other things that we do, so we have Zulu builds of OpenJDK, but we also have what we call Zulu embedded. And so we provide versions of Zulu that run on ARM processors, both 32 and 64-bit versions. We have PowerPC and we have MIPS. So yes, there is a PowerPC version available. You can talk to, you can look on our website and contact us if you want more information about that. But we do have PowerPC available. Yeah, so I think that's the, oh yeah, okay, good. Yeah, so those are the only questions that I see on there. So I would say that I hope this has been useful. I hope this has been interesting in terms of understanding more about how to keep your applications secure by keeping your JDK updated. And I would say thank you very much.